All right, so 5.2, we're going to be finding the zeros and graphing polynomials. So when we graph, we need to remember what we learned on Monday with our end behavior stuff. So find the zeros of the function. So we've done this before. When it says find the zeros, we solve, but it pretty much means that y is 0. So we've done this with factoring, but it's already factored for us. So we set each piece equal to 0. So I have x is equal to 0, and x minus 6 is equal to 0. So x equals 0 is already solved for us. We don't have to do anything there. And the second one, how do I solve for x? Add 6. So what does x equal? 6. So those are zeros. So the next one, find the zeros. So we change y to be 0. And then what do I have to do? X plus 4 equals 0. And x minus 5 is equal to 0. So then we just solve for x. Subtract 4 on both sides. So x is equal to what? Negative 4. And add 5 to both sides. So x is equal to 5. So those are our two answers. So if you wanted to, you could write it as x is equal to negative 4 and 5, like this. This is the same thing. You can write it either way. So for the next one, find the zeros. Change y to be 0, and then what should I do? X plus 12 equals 0. X minus 9 is equal to 0, and x minus 7 is equal to 0. So we have 3 mini equations in here. So subtract 12 on both sides, so x is equal to what? Negative 12. We add 9 to both sides, so x is equal to 9. And add 7 to both sides, so x is equal to 7. So notice that our answers are the same as what we started with, but the signs are different. So we are changing the signs in our answers. So instead of a plus 12, it became a minus 12. Instead of a minus 9, it became a positive 9. And instead of a minus 7, it became a positive 7. So we're going to incorporate what we just did into graphing. So we want to find the zeros. So the 0 is where it crosses the x-axis. So first thing we do is find the zeros. So I have x minus 1 is equal to 0. X plus 2 is equal to 0. So what are my zeros? X is equal to what? 1 and negative 2. So on my graph, I'm going to put a point at 1 on the x-axis and negative 2 on the x-axis. So these points go on the x-axis. Not yet. Do we have a graph yet? No. So the next thing we want to do is find the end behavior. So just like how we did before, if we have, if we have x raised to an even number, what direction does my end behavior do? It goes up and up if it's positive. If it was an odd number, so a positive odd number, what direction would my arrows do? What would the right arrow do? Go up because it's positive, and so the left one goes down. So this is what we did in 5.1 with the arrows. So we're doing it again here to help us graph. So how many x's do I have? In my equation, how many do I have? 2. So this is like an x squared graph. Do any of those x's have a negative in front of them? No. So they're both positive, so it's a positive x squared. So what's my end behavior going to do? Up and up. So from my point farthest to the left, I go up. From my point farthest to the right, I go up. And then in between, you just kind of connect the dots below. You don't connect it like straight across because we don't have any other points besides these two on the x-axis, so you just connect it down below, like that. This is a rough estimate kind of our graph. When we have like more than just two x's, like we do the same thing. But here we don't know really how far down that u goes, so this is just like a rough estimate. Our graph has this shape, but it's not this exact graph. But all we need is the shape of the graph for these. It doesn't have to be exact, so all we do is just connect the dots. So let's go to the next one. First thing I do is find the zeros. So x is equal to what? 2 and -9. So we just change the signs. So x is equal to 2 and -9. So I'm going to put a point at 2 and a point at -9. How many x's in total do I have here? 2. So this is an x squared. Do any of those x's have a negative in front of them? No. So what's the end behavior of my graph going to do? Up and up. So out of my point farthest to the left, I go up, and out of my point farthest to the right, I go up. And then I just connect the dots. All right, so the next one. What does x equal? 0. What else? -5 and 8. Perfect. We just change the sign of each of them. Don't forget that when you have an x outside, you need that x is equal to 0. So I'm going to put a point at 0, -5, and +8. Next, I need to check the end behavior. How many x's total do I have here? 3. So this is an x cubed graph. Do any of them have a negative in front of it? No. So it's a positive x cubed graph. So what do the arrows for a positive x cubed graph do? Down and then up. Perfect. So this is my left arrow. This is my right one. So out of the point farthest to the left, I go down. Out of the point farthest to the right, I go up.
How do you indicate arrows again? It's like for the right one.
So since it's positive, the right one goes up. So that's the first one that we always do. If it's positive, the right one goes up. And then if it's odd, they go in opposite directions. And then in between, we connect the dots, but we can only cross the x-axis at our points. So we cross here, we cross again here, and then we cross here. So we kind of just snake it through. So you can only touch the x-axis at one of your zeros. All right, first thing we want to do here is find our zeros. So what does x equal? -1. What else? +2 and +3. So x is -1, +2, and +3. Now we want to figure out our end behavior. So how many x's do I have? 3. Do any of them have a negative in front? No. So it's a positive x cubed. So what direction are my arrows going to go? Down and then up. So this is my left one, this is my right one. So out of the point farthest to the left, I have an arrow going down. Out of the point farthest to the right, I have an arrow going up. And then in between, I connect the dots, but you can't touch the x-axis and anywhere else other than your zeros. So I have to cross it here, and cross back here. So you cannot touch the x-axis other than where your zeros are. Okay, I'm going to do one more example on the side over here, so if you want to write it down. Okay, so we have y is equal to x times -x plus 3 times x plus 6. We're going to have to graph it. Okay, so first thing we want to do is find the zeros. So I have x is equal to what? 0. For this one, it's a little bit different because I have a negative x, so you don't just change the sign of that number. So you have to set negative x plus 3 is equal to 0. Now, how can I solve for x? What do I do? Add what? I can add x to both sides. So I have 3 is equal to x. So x is 3. And then in the other one, I have x plus 6 equals 0. So what does x equal? Negative 6. So notice how here we didn't just change the sign because it was a negative x. So it's a little bit different. So just do the math and find x. So these are 3 zeros. So where am I going to put points on the x-axis? At what numbers? At 0, 3, and negative 6. Now I need to check the end behavior. How many x's total do I have? 3. So it's an x cubed graph. Do any of those x's have a negative in front? How many of them? 1. So it's a negative x cubed graph. So what do my end behaviors do? So it's negative, so the right one goes down, and then is it even or odd? It's odd, so what does the left one do? Up. They go in opposite direction. So up, then down. So the left one is up, the right one is down. Because it's negative, so our right arrow went down. Yes. When it's odd, they go in opposite directions. So the left one, we go out of our point farthest to the left, it goes up. Our point farthest to the right is going to go down. And then what do I do in between? I just connect the dots, but you can't cross the axis anywhere besides your zeros. So our graph looks like that.